Now, I want to finish off essentially the serverless stuff with you today. There's lots of serverless services that we won't get to look at, but we've covered quite a lot. And also, I want to talk about the assignment one specification. So we'll go into here again, and I'm going to work my way through these slides here. And the lab accompanying them is this lab here. And you will need to submit this lab. Also, I hope to publish the results belatedly, admittedly, of the TypeScript lab. If you remember, you submitted that quite a number of weeks ago now, so apologies for not getting back uh, or not getting to correct those sooner. So anyway, we'll work our way through these slides here. And I started talking about them the last day. So what we want to look at is developing a web API using a serverless kind of theme. Now, we're all very familiar with the notion of web APIs, so conceptually, there's nothing really to overcome from your perspective anyway, because you've done a lot of web API stuff in the previous semester. The AWS service that's involved here is called API Gateway. And I'm saying it kind of falls into the kind of communications groupings of services because essentially it allows not just external clients, but also internal clients to communicate with a web API. And okay, kind of formal definition of what the API Gateway service is all about. It's a fully managed service, and we know now that's a byword for serverless. For creating, I'm saying publishing, maintaining, monitoring, and securing both REST APIs and HTTP APIs. The only difference between a REST API and a HTTP API is very much a kind of AWS terminology now, but their distinction between a REST and HTTP is much more kind of lightweight. It doesn't have as much features to it as a REST API. We will be using the REST side of it. It also supports WebSockets, which are kind of server-side push support. We won't get a chance to look at that either. So you can use the API Gateway service um, to just one second. For creating, publishing, maintaining. But of course, we're going to be using the CDK to do that for us. You can do all of this manually from the gateway service itself, as indeed you could have created Lambdas manually using the Lambda service, and you could create a DynamoDB database manually using the DynamoDB service. But we're all into infrastructure of code, so we're not looking at that side of API Gateway. You can use API Gateway as well for monitoring. Again, we won't get a chance to look at that. Monitoring as in, how much traffic is targeting your web API. Are there fluctuations in it depending on time of day, etc. And always security is a big issue with any aspect of AWS. And we will look at one part of security, or at least it's going to come into the assignment actually, as it turns out. In the image here, I'm showing you the kind of classic example of where API Gateway fits in an overall architecture. So typically API Gateway is it's a client facing, if you like, the client being over here. It's a client facing interface to some backend functionality, which in our case anyway um, is typically contained within some set of lambdas. So the assumption is there's a whole bunch of lambda functions here behind. So the lambdas are what we might refer to as our backend. And the gateway then is a single point of entry to all of these Lambdas. We know when we talked about Lambdas that you can get the Lambda servers to generate a URL specific to a Lambda, but that means then that each Lambda has its own URL access point, and that's not great really from a design point of view. Now the API gateway has a whole bunch of Web API related features to it, many of which we won't get to look at, but just to quickly go down through them. When you're developing a web API, this is kind of in a production environment now. Presumably, your web API evolves over time, so you will have different versions of it. But clients that might have used version 1 may still want to continue on using version 1. They may not be in a position to use version 2 of your web API because in order to use version 2, clients would have to update their code. So the client might be a React app, for example. And so if you've made some significant changes to your web API between version 1 and version 2, then whoever developed the React app has to go making changes to their code. And that may just not be feasible for whatever reason, which means that ideally you'd like to be able to have both version 1 and version 2 available to clients over a long period of time. And so API Gateway can handle that kind of parallel support for two different versions of the same web API. The backends might change as well, um, but the gateway service and it makes it easy for the API developer to have a number of different versions of the API supported concurrently. You can also you may want to be able to support different environments, where environments typically mean these kind of environments here. Although you're not restricted to dev, test, and prod. You might have a dev, test, staging, prod environments. But either way, a bit like versioning, but different kind of context. The gateway supports different environments as well. Security, as I said, is always a big issue, and it's kind of integrated with uh, IAM and another security-related service called Cognito. What else? Creating API keys. We are familiar with API keys from the TMDB development that you would have done in the first semester. Well, you can get the gateway servers to generate an API key or keys for a particular web API. That's going to be relevant to the assignment as it turns out. And the whole point of, well, one of the reasons why you might want to have clients use an API key, obviously from an authentication point of view, but also you can use keys to support what's called throttling. If you want to put some sort of rate limiting use on your web API from the client's perspective, you can define what rate limits are associated with a particular key. It supports Swagger and OpenAPI. I'm sure you've heard of Swagger at some stage during the Web App Dev 2 module. Swagger is a way of describing a web API structure. So you could actually upload a Swagger document to the API Gateway service and it will generate the web API for you. Now, we're not going to use that approach. We're going to use the CDK approach instead. Support for WebSockets, I've already mentioned. Uh, when you communicate with a web API, perhaps you may want to do some validation of the request before you forward it on to the backend, or you may want to do some transformation of the request before you forward it on to the backend. particularly now, this would be for, let's say, HTTP post requests where there's a payload associated with the request. So you may want to transform and or do some validation of the payload. You can actually configure API gateway to do that. Alternatively, you do it within your Lambda function, but it's an option to let the gateway do the transformation validation. Um, you can actually get it to generate an SDK for accompanying your web API. And of course, the advantage of generating SDK is that the clients, they no longer have to make raw HTTP calls to your web API. They can now use kind of a more programmatic approach uh, towards doing that. We won't get to look at that either, I'm afraid. Caching, you can get the API to get gateway to cache responses to requests so that you can reuse those responses, and it's supposed to do DDoS as well. So there's lots of features to Gateway if we had the time to explore all of them. Now, so here's our gateway, and what lies to the right of the gateway is what we call the back end. Now, it turns out that the back end can be and could be one of a number of different types of backends. Like if I go back a couple of slides, in this slide here, the backend is Lambdas, but the backends could be other types of resources as well. And so that means that you need to, the way you kind of integrate API gateway with the backend depends on what the nature of the backend is. Okay, and so that's what we're talking about here. We refer to that as the integration type for your web API. And it turns out that there are one, two, four different integration types supported by the gateway service. The first one is a kind of default one, where it's called the mock integration. That's where you actually don't have any backend at all. And you would typically use the mock integration type for your web API if you hadn't actually developed the backend yet. You're only concentrating on developing just the web API interface part to it. And so if you say that a particular web API that you're creating has mock integrations, then you're essentially saying there is no backend yet. And in that case, the API gateway will actually generate kind of default responses to requests that it receives. The next, now, when you read about these integration types, they're kind of given slightly different names by different authors, which is kind of unfortunate. And even AWS's own documentation, they use slightly different names for the integration types. And I've tried to cover all bases here. Sometimes you come across the HTTP/AWS integration, also referred to as just the AWS services integration. Well, for that integration type, uh, we are saying that the backend is certainly not going to be a Lambda. It's going to be some other type of resource. And in the image down here, I'm giving you one example. It's where the backend is actually an SQS queue. I'll talk about SQS, the SQS service, in a future lecture. But either way, because it's an SQS queue, that means that the gateway has to carry out a transformation from the HTTP protocol, which is what it receives, to the protocol that this backend understands. And that transformation has to be described in some way. And what we use are what are called mapping templates to describe the transformation that needs to be carried out. These mapping templates are written using a special kind of tool, and they're quite tricky things to write. Fortunately, we don't need to know about them, but Uh, so the kind of transformation has to be, you have to explain to API Gateway how it transforms the requests into a form that it can pass on to the backend. And we do that using what are called mapping templates. And we associate the mapping templates with our particular web API. So that's two types of integrations. The next type of integration, number three, is the one that we're most interested in. And sometimes it's called AWS proxy, sometimes it's called Lambda proxy. And it is the integration type of your web API when the backend is a Lambda. So because that's probably one of the most commonly used one, in this scenario, we don't have to worry about mapping templates because the API Gateway Service knows how to map from HTTP to a form that it can pass on to the Lambda. Now we know that a Lambda function expects to receive an event. Remember when we started talking about Lambda way back, we said it was an event-driven uh, service. And we know that when we actually write our Lambda functions, the first parameter of the handler is the event object. And so what the gateway does is it takes the HTTP request, which will include things like request headers, query strings, path parameters. It'll take all of those and it will put them into an object, which is essentially the event object that the Lambda expects. Puts lots of other stuff into that event object as well. Um, but as we'll see in a while, the event object that it receives when it's receiving it from API Gateway. So API Gateway now is essentially the source of the event that is going to trigger our Lambda. And the event object will essentially contain lots of information about the HTTP request that was the originator for the particular event. Uh, That's integration type number three, and integration type number four is simply called HTTP proxy. And this is useful when it's both HTTP here and here. Okay, so really the gateway has very little to do. It simply takes the HTTP request that it receives and it just proxies that HTTP request onto the backend. An example of a backend in this case would be a load balancer, which for those of you that has studied some AWS in previous years, a load balancer expects to receive communications over the HTTP protocol. So again, there's no mapping templates or any transformations required in this case either. Okay, that's fine. So that's what we call integration types. And the integration type that we are most interested in is the what's called the Lambda proxy, or sometimes called AWS proxy. When you're using API Gateway, because it's a HTTP based resource, I suppose, then we're always interested in CORS, and we know what CORS is from our other web studies. But just to so what I'm showing you down here is, so here's my API gateway. Here's where my web API is essentially going to be, and my web API will have a domain name. So in the screenshot, the domain name is www dot api.example.com. Now, if it receives requests from a source that is related to another domain, then API Gateway has to make a decision. Do I allow requests from that other domain to be received by this web API and proxied on to the backend? And that's what CORS is all about. And in the kind of example I'm showing you here, let's supposing I've got a React app, which you can actually you can actually deploy a React app into an S3 bucket. S3, as some of you will know, is another one of AWS's services. We haven't looked at it so far. Probably won't look at it at all, actually, although we will use it. But it's essentially kind of a file storage service. But the AWS people do actually allow us to use an S3 bucket, which is a bit like a folder. We can configure that folder to be a static website server. So if I've uploaded my React app to an S3 bucket, I can associate a domain name with that website stroke React app. And so if the domain name uh, is what is www.example.com as opposed to apiexample.com. So there are two different domains. That means that when my React app sends a request to API Gateway, because it's two different domains, then the way it's going to work, as you know, is the React app, well, the browser really will send a what's called a pre-flight request. Pre-flight request, essentially asking the gateway, do you accept requests from this other domain, i.e., www.example.com? The gateway will respond will respond telling it what domains it accepts requests from and what methods it allows. And when that is received back by the browser, it will then decide whether it can actually send the request or not. That's just the way CORS works. Okay, so it's not an API gateway thing. It's a HTTP protocol um, feature. But all I'm getting at here is that when you create a web API using API Gateway, you do have to configure the core settings for that web API. Let's take a simple example, and we're kind of want to go back now to the CDK stack world, and we want to create a web API from a CDK stack. So we'll take our kind of classic 101 example. Our web API has two endpoints, let's say, the slash to-dos endpoint, and it supports a GET request to that endpoint, and that is meant to return all the to-dos that are being stored in your database. Now, we're not going to worry about the database side of things at all. It also accepts post requests to this endpoint, and that is a way of adding a new to-do to your database. The second endpoint has a path parameter, where the path parameter is meant to represent the ID of a particular to-do, and it only supports GET requests. Okay, so they're my two endpoints for my web API. And I want to use the CDK framework to create a RESTful web API that supports these two endpoints. And uh, let's look at the code, I guess. So here's my CDK project, and here's the stack file. So if we take it from the top down, and I've already deployed this now for convenience. So let's see. Oh yeah. So just for convenience now, I have just want to sorry now, just want to drop that. For convenience, I just have one Lambda, which is going to be, if I go back to my slides, purely for convenience because we don't really care about the functionality associated with, reading to-dos and adding a to-do and reading a specific to-dos. So I've just got one Lambda that's going to be handling all of these requests. And the Lambda actually doesn't do anything, just as a console log and nothing else. Yeah, maybe I should show you the Lambda first. That'd be a good idea. So if I go into the Lambda folder, here's my Lambda. And as I said, there's nothing on console log and just sends a response back. This is the response that would be received by whatever client issued the request. So the Lambda isn't the backend isn't really of any interest to us today anyway. So here is my code to create my Lambda function. So we can skip over that. Here's how I create my REST API. So there's an L2 construct called REST API, which is part of the, where is it? Part of the AWS CDK lib API gateway package, if you like. And as with all L2 constructs, we have to say what's the scope of this construct? In other words, what do we want to attach this construct to? We want to attach it to the current stack. That's just an identifier for the construct. And the rest then is the configuration of this particular construct. And because it's a REST API, some of the things we need to indicate are uh, the environment that we want to associate with this API. Now, I've just arbitrarily decided that it's going to be the dev environment. So we don't talk about, well, it doesn't use the language environment here. It talks about stages of your web API. So dev, prod, test would be different stages. And the stage names can be anything, but conventionally they are dev, prod, and test. And here we go. Here we are defining the CORS configuration for this web API, and it essentially allows every type of request. What am I saying here? I'm accepting requests from all of these methods from essentially any domain. So it's pretty open-ended, but I do have to specify some default CORS settings. Okay, so that essentially creates an empty, if you like, web API. I don't have any endpoints yet. The rest of the code now is about adding endpoints to this web API. We don't use the word endpoint, we use the word resource in CDK language. So I'm taking my API and from the root path, I'm adding an endpoint or resource, and the path of the resource is to-dos. So the effect of this line here is essentially to add this path or this endpoint to my API. There is some other kind of configuration options, but we're not using them here. So that adds an end, this line adds an endpoint. The next thing I need to do is specify what methods that endpoint supports. And that's what I'm doing here. So it looks like it supports the get method. And here I am saying what type of integration does this endpoint require? And Lambda integration is the CDK class for, as you might guess, Lambda proxy integration type. Okay, so Lambda integration is this integration type here. So we create a new integration using this convenience class. We need to specify the Lambda function. So that's just a reference to my function that I've defined up at the very top here. And proxy true is just a uh, kind of a setting that we need to enable. So that's fine. We can now send GET requests to the /movies endpoint. We're adding another method. Sorry, we're not. We're adding, oh yeah, sorry, here we are. We're adding a second method as well, which is the post method, Lambda integration. And as I said, I'm actually sending my post and GET requests to the same Lambda function. So all of that code now from here up, all of the code that I've highlighted there is implementing uh, essentially all of this here. Next, I am creating a new resource, but I'm adding this resource onto the other resource. Whereas in the earlier case, I was adding the resource to the root of the web API. Whereas now down here, I am adding a resource uh, to the existing endpoint, if you like. And that makes sense because, again, if I go back to my slides, I'm essentially uh, just adding this bit here onto this bit here. And in this case, the resource string, if you like, is because it's got the curly braces around it, whereas up here it was just a simple string with no kind of formatting. Because it's got the curly braces around it, that means now that that will be interpreted as a path variable. And again, we're adding methods, well, only one method in this case, to this second endpoint. And that's it, right? So one Lambda, a REST API, and some endpoints. I don't have to do I don't have to output anything from this stack by default. When you create a REST API and when you deploy the stack, you will get the URL of the web API as part of the output from the stack. And, if I show you, because I deployed it earlier on. So here's the URL of that web API. So if I simply copy that and go over to Postman, which I think I've done it already actually. And here's my Postman collection. And as a variable, I've declared a variable called URL. And I think that's the URL. I'll just try it anyway. That's the URL that we saw in our VS Code. And so let's suppose we want to do a get to the slash to-dos. Just get rid of 1, 2, 3, 4. Now, maybe before I just do that, maybe what I should do is, first of all, if I go to the API Gateway service on the API Gateway console, which is this one here. And if I select APIs, so this, there are two here now because there's another one that I need to look at it in a while, but this is the API that was deployed from the stack that I've just been looking at. And if we go into that web API, we get a nice kind of visual representation here of the different resources, as AWS calls them, but we would call them kind of endpoints. So it looks like, look, there's a to-dos endpoint. It supports get and post. Every endpoint supports the options method. Then we have the slash to-do ID, which is tagged on to to-dos. It only supports the get. And if we select any one of these, let's say we select this one, on the right here, we gotta get a visual description of that endpoint, and you can see uh, that the integration type here is to a Lambda. Yeah, so that all kind of adds up. Um, so, and I've gotten the URL of this web API. So now I should be able to send requests to it. And so let's do that. So this is what we're getting back, and hopefully that tallies with the Lambda that we're using. And if we go back to our CDK or to VS Code, look at the Lambda, then yeah, that seems to add up because that's what's coming back in the response. If I send another one, this time I will target the second endpoint. And because it's the same Lambda, we're getting the same response. But if I go to, because in my Lambda, I'm doing console log of the event that was provided to it by API Gateway. So if I go to CloudWatch logs, so this is the log group of my Lambda function. And here's the log stream. And I invoked it twice, so it's actually using the same micro VM. It didn't create two separate ones, which kind of makes sense. But what I want to look at is what does this console log look like? And I can pick either of them really. I'll pick the second one because it's slightly better, which is this one here. And so this is the event object now that my Lambda receives. And okay, there's a lot of stuff here that, well, here are the various headers that were included in the request from Postman. In my case, that was the client, most of which we are not particularly interested in. If I keep going on down, well, in fact, if I go back up, I can see here, look, this was the actual path. It was a GET request. So I can find out a lot about the request from within this event object. This is the event object that we're looking at now. And in terms of well, there wasn't any body in this case, but if there were query strings, I could get at them from here. If there were path parameters, I could get at them here. And I do have let's trigger the post as well, actually. Uh, so here's my post. And supposing this is the to-do that I want to post. So I'll send that. Now, yet again, it's the same lambda, but can we get at this? How do we get at this payload from within the event object? It's pretty straightforward. So if I do a refresh on this, so I'm going to guess now that this is the console log of the event for the post. And if we go right down to the end of it, it's a lot there actually. You can see here's the body. This is the body of the request, or the payload of the request that was sent by Postman. And it's a stringified version. That's a stringified version of this JSON object. So all we would need to do in our Lambda is just parse that string, parse this string using the JSON built-in library, and we now have the payload in JSON format, and we can process that. So it's pretty straightforward, I think, using API Gateway so far anyway. I pause just for any questions in case there are any. No? Okay, let's move on. Um, I Well, I haven't illustrated this now, but can I illustrate it? I can actually. What I'm getting at here is if your request to API Gateway includes um, a query string, and we know a query string is a set of key value pairs, then what the gateway will do is um, it will split up that string and put it into a nice JSON representation and include that in the event object. So, do I have an example of that? Yes, let's enable these two here actually. So supposing I'm going to get rid of, I can leave it there, it doesn't really matter. So I've got a query string here, as you can see. And uh, how do we get at that query string in our Lambda function? So let's send this request. So my query string is completed equals false and contains equals lab work. So maybe the contains is kind of a search criteria, and we're also saying we're only interested in to-dos that have the completed property set to false. I guess that's what we're trying to get across there, even though we don't have any real database. But so let's send that request and go back to our CloudWatch logs yet again. Refresh this again. Hopefully it is updated. I'm going to gamble now and assume that this is the console log corresponding to that. No, it wasn't. Let's go back here to refresh. Yikes. So I'm going to say this is the log stream here. What time is on it? 1324. That's probably right. So it used a different micro VM for the Lambda instance, it looks like. But in terms of the query string, here you can see the query string. So what we're looking at now is the event object that my Lambda received. And within the event object, there's a property called query string parameters, and it's a nice JSON representation. So again, I can get at the query string within my Lambda when the request came via API gateway. Right. Similarly for path parameters, and I'm not going to show it now, but you can see here, look, there is another part of the event object called, oh, look, we actually have it here, path parameter, and it gives you the parameter name and the value. And if there were more than one parameters in the path, then, there would be individual keys within this object. So the overall point anyway is that we can really get at any part of the request, the HTTP request from within the event object of our Lambda, whether that be query string, path parameters, um, request headers, they're all there available to us. Right. What I'm now going to do is I am going to park API Gateway because we're actually not going to look at any other aspects of it. So I'm going to go back now to the website. And as I said, you need to walk through this example here, or this lab, which will involve creating a web API front end to a couple of lambdas, where the lambdas actually talk to our movies database. So the movies is the kind of context again. So walk your way through that lab. Take a little bit of while to work your way through it. And once you've done that, then you have a very good foundation for the first assignment. So you do need to work through this lab first before you would be able to tackle the assignment. And so let's talk about the assignment. Hopefully you've read through it since I advertised it there yesterday. So I'll quickly go down to it. So it's about developing your own web API. And I'm saying develop it for a context of your choosing. Okay. For example, you might have in your final year project, you might have some database part to your project. Just take one part of that database and let that be the context for your web API. You will only need one DynamoDB table in this assignment. So just as I said, in your final year project, if you do have a database, you probably have a number of tables, whether you're using a relational or a non-relational database. Just take one part, one particular part of your entity relationship model, if you like, and model that as a DynamoDB table. That's fine. I'm setting that as the completion date. This is worth 30%, this assignment. The deliverables are similar to other assignments that I've given you in other modules. You just upload a text file. Please make sure it's a text file. Do not upload a Word document or a rich text file. Just create an ordinary TXT file. And in that file, you'll have just the URL of the GitHub repo that you'll use to host your code. Now, in this case, I am requiring people to actually set the visibility of their repo to private, so that avoids any possibility that people may try and plagiarize your work. So set your repo to private, and then when the completion date has passed, I will remind students that they need to now change their repo to public visibility so that I can actually access it. I don't want people inviting me as a collaborator to their repo. That just takes a little bit extra work on my part to go accepting all of these things. So initially set it to private, and then I will tell you when you need to open it up to public visibility. You'll also do a short video demonstration of your web API. You'll essentially be demonstrating it using Postman to prove that it all works. As always, there will be a README, and I'll provide a template for the README of the repo. It will take you very little time to write up that README. As always, you need to maintain a Git log of your work. I don't need to talk any more about that. People should know by now that I do put a lot of emphasis on using Git right throughout the project, or the assignment, sorry. Just some detail then on the actual, what I'm looking for in this web API. So your web API should support a post, and you don't need to have any more endpoints than what I'm listing here. Okay. By giving me lots of other endpoints, unfortunately, it won't get you any extra marks. So all you need is one post endpoint for the purpose of adding a new item to your particular table. Simple as that. You'll need a parameterized get endpoint, where the parameter I'm saying is the partition key, not the primary key now, the partition key for your particular table. And that get request should return the collection of items that share that partition key. So if we just use the movies example, because that's what we know about, the partition key of my movies table was movie ID. Well, sorry, let's not talk about the movies table. Let's talk about the movie cast table. In the movies cast table, the partition key was movie ID, but because we had a number of cast members in a movie, then a get request with movie ID would return a collection, would return all of the items, all of the cast member items in my table. Similarly for your case, so the assumption now is that your table will have a composite primary key. That's a requirement. What that composition is depends on the nature of your table. So you do have to design that yourselves. So the parameterized get will just return a collection of matching items based on partition key. The next bullet point says, look, take this parameterized get and also support a query string option within it, where the query string would actually specify the sort key value of the item you're looking for. Yeah. Okay. That's straightforward enough, I hope. The next endpoint is a push. So far now we only have essentially two endpoints, a post and a get, because these two bullet points here are really relating to the same endpoint. We've got a put endpoint that allows you to update a table item. And finally, we've got another get endpoint, and this is very specific. This is a get endpoint whereby the Lambda is going to be using an AWS service that we haven't looked at called the Translate service. So the assumption here is that in your table, there is a particular attribute within the table that contains some sort of description field, or it contains a text, some text, like a sentence or a couple of sentences as its value, which, for example, might be a description, whatever description means in the context of your table. And this endpoint here allows users to request uh, the retrieval of a particular item, one item in your table, but the description field or that text field has its content translated into another language of the user's choice. So here might be kind of an abstract example of the path for this endpoint. Slash things slash the partition key of the thing that you're interested in, slash the sort key. So that combination of sort key and partition key will specify one particular item or record within your table. And then we've got a slash translate part to the path name, followed by a query string, where the query string key is language and the value is a language code. And these codes are kind of standard codes for natural languages, FR, for example, being French, EN for English, etc. Okay, come back to me now if you're not clear on what I'm getting at there, but we'll just move on. I have some requirements on the database, the DynamoDB table. I'm saying you will only and should only have one table in your stack, where that table has a composite primary key, as I've already mentioned. Okay, the attribute should be a combination of scalar values, number, string, Boolean. If you don't have a Boolean, it won't be that put out by it, but try and have a combination. And even if it means having to slightly make up a property so that you satisfy these, that's okay as well. And also one attribute within your table design is what I'm calling a string-based attribute. And it's this string-based attribute that will be the subject of the translations. So again, if you have to artificially add an attribute to your item design such that it has this kind of string-like a string-based property, then so be it. So this string-based property of an item would typically contain a complete sentence or a couple of sentences which are suitable for translation, for the translation endpoint. So nothing other than that. It's pretty open-ended in terms of the design of the table. From an authentication point of view, we're going to be using API keys, and I do need to talk a little bit about API keys because we haven't spoken about them so far. So I'm just saying specifically the post and put endpoints should require the inclusion of an API key in the requests. Now, API Gateway expects to receive an API key in a particular HTTP request header called the XAPI key header, which I'm giving you that for free. I'm telling you that that is the particular header that you include in your request. So it's only the post and put that need to be protected. Here I'm talking a little bit about the Amazon Translate service, and I'm giving you a link to a video which you should watch. It's only about a 30-minute video in which the presenter explains exactly how you use the AWS Translate service within a Lambda. So once you watch that, and he may actually include a reference to his GitHub repo so that you can look at that and the actual code, and you can cut and paste out of that if you need to. I'm also giving you a link to the AWS Translate docs, but I don't think you'll need to go near those. You'll certainly need to watch that. Now I'm adding in a little extra point here, which is, so I've got this endpoint in my web API, which allows users to request the translation of the text property or string-based property of a particular item in your database. But if your web API receives the exact same request multiple times from different clients, let's say, then that means they have to call the translate service every time, and that costs money. So it would make sense that uh, you should, in a way, kind of cache the translations so that you can reuse them for subsequent requests. Now, we're not going to use official caching technology. We're just going to use our database as a form of a cache. So that now means when your web API receives a request to carry out a translation, that request is going to be received by the particular Lambda that's dealing with that request. The first thing it should do is check to see in your database, do you already have a an entry in your table for the translation for that particular item for a particular language. And if you do, then just return it from the table. You don't have to go talking to the translate service or not at all. If you don't, then send the request on to the translate service, and the response that you get back from the translate service, store it in your database, and then send it back to the client, Postman in your case. So you need to do a little bit of extra stuff, both really at the Lambda level to meet this requirement. Grading spectrum. Um, I mean, you can read these yourselves, right? So I'm just going to scan down to them. It's not until we get to, okay, so in the very good, you'll have to start doing using the translate service. But in the very good grade, you won't have to worry about the essentially persisting or caching of your translations. That doesn't uh, come into focus unless you're aiming at the excellent grade band. So in this grade band, you're going to be persisting the translations, and it's also where you're going to start introducing your API key. So you're going to have your post and put as protected endpoints. And the final grade band, I'm talking about something called custom constructs, which I need to talk to you about. And I'm talking about something called Lambda layers, which you would need to read up on, or multi-stack apps, which you would also need to read up on. So there's three things you need to do a little bit of research on. API keys, number one, Lambda layers, number two, multi-stack apps, number three, or pick one of them really. You don't have to do both of them. And I'll talk a little bit about custom constructs as well to you. Now, before I go on, I'm going to pause and again give you a chance to ask any questions if you've got any questions so far. No? If I go back to my slides, so I've got two slides here that gives you an overview of the use of API keys in the API gateway service. But there isn't enough information. I'm not giving you any code excerpts. So unfortunately, and by code I really mean CDK code. There's nothing in the Lambda side that is affected by API keys, because API keys are going to be used by API gateway to determine whether it should proxy a request on to the backend or not. So this really is only concerns your stack code. But well, what are API keys? And of course, you already know the answer to this. They're alphanumeric string values that you typically you provide them to developers, really tend to developers rather than ordinary users. And it allows your developer to write client code which can interact with your web API. Yeah. Uh, as you did with the TMDB, for example, except, uh, well, okay, that you know already. Uh, okay, and you can, okay, I'm saying here you can generate an API key in your using the API gateway, which means we can generate them from within our CDK code. You can go directly to the API gateway console and generate them there, but we don't want to take that approach. We want to take an infrastructure as code approach. You can also, just by the way, you can actually import API keys. So if you've got some other service that generates them, which really doesn't apply in our case, but if you do have that kind of setup, then you can actually import keys into your API gateway for a particular web API. So that's API keys, but there is a second uh, concept that applies to AWS's API gateway service, and it's something called a usage plan. And what a usage plan is a way of specifying what particular kind of access do you want to allow a developer to have, and you tend to associate a usage plan with an API key. So the API key kind of says whether you can do anything, access any part of the web API. The usage plan talks about what kind of access are you allowed. And it can do things, you can specify things like rate limiting, which really doesn't apply to us, but you can, and um other ways of controlling the access to your web API. So if I would just read it, it specifies who can access one or more deployed APIs. You can actually associate the same usage plan with different web APIs, so they're kind of independent of a web API. You can create them separately, and then you associate them with one or more web APIs. And that association is done within your CDK stack. And also the creation of your usage plan you can do programmatically within your CDK stack. You associate a plan with what's called a stage, where the stages are, as we've already mentioned, kind of dev, prod, test. So you've got a lot of kind of flexibility in terms of what kind of access you want to give developers to your web API. Maybe you only want to give them access to the dev version of your web API and not the prod, or whatever. You can also control throttling, as I've already mentioned. The plan uses an API key to identify the API client. Yeah, that's okay. I've kind of already alluded to that. What I try to do is give you what I'm trying to do here is give a kind of a visual representation of how these different concepts tie together. So I have a RESTful web API. That's what I'm representing here. I've also created a usage plan for myself. And as I've already said, you can create a usage plan independently of a REST API. The usage plan, and it's important the direction of the arrows here now, the usage plan essentially points or refers to a web API. It's not the other way around. So you're associating a particular web API with a usage plan. And as I said, you can associate multiple APIs with the same usage plan. Also, you associate an API key, which is a separate thing that you can create. You associate that with you associate a plan with an API key. So that's how these there are three kind of resources, to use the AWS world terminology. There are web APIs, usage plans, API keys, and you kind of connect them up together to get the effect that you want to. Down here, I'm just using this kind of symbol to represent endpoints. So my web API let's say it just has two endpoints. This one here is completely open-ended. It's public, so it doesn't have any associations with usage plans or API keys. Whereas this endpoint over here, I'm using this lock symbol to indicate we want this to be a protected endpoint. And so it won't have a direct connection with the usage plan, but because the usage plan is linked to this and the usage plan is linked to this API key, because I've indicated in the configuration of this endpoint that I want this endpoint to be protected by an API key. I don't have to specify what key. I just indicate that I want this endpoint to be API key protected. Then API gateway will know, well, this is the actual key that it only will allow you clients to access this endpoint. If this API key is not included in a request, then it won't be able to access this endpoint. So don't know if that image helps you at a very high level, admittedly, to understand what's going on here. Now, of course, what you've got to do in your CDK code is find out, how do I create a usage plan? How do I create an API key? How do I connect the usage plan to the key? How do I connect the usage plan to the web API? How do I indicate that a particular endpoint needs to be protected? All of those things you're going to have to, unfortunately, do a little bit of reading up on yourselves. What I've done just for illustration purposes is I've implemented this, but fortunately I can't show you the code, but I'll just show you it working. So if I go to the web API that, let me just switch over to it. So this is the web API. Actually, it's the one that you're going to be developing in this week's lab. But the idea is I have an endpoint that allows me to get a movie. I have an endpoint that allows me to get movie cast and etc. etc. There are a couple of endpoints, but the only endpoint that's protected, and I just arbitrarily chose one, it's the endpoint for getting a movie. So I've written my CDK stack, which includes all the stuff related to Lambdas and web APIs and endpoints, but it also includes the code for generating my usage plan and my API keys and connecting them all up. And I've deployed that entire web API. So now if I want to try and get it working, or sorry, if I want to try and invoke it, the first thing I'll do actually before I invoke it is if I go to the management console and if I go to the API gateway service, so it's this web API here. Okay, let's go into it. So look, it has these kind of endpoint slash movies that supports a get and a post slash movie slash movie ID, supports a get and etc. etc. If I go over to the left here, you'll see down here I have API keys. And if I click on that, lo and behold, I do have an API key that has been generated for me. That was generated by my CDK stack. And that key, this is the actual key value itself here. I mean, we don't really need to see it. It's just a big long string. But if I copy that, if I do a copy of that, and if I go over to Postman, and I have my collection here, this is the collection that I'm going to be using. And in Postman, I have two collection variables. The URL is just the URL of the web API itself, which I've already set that up. And I've got a second one, which I've just called API key. Doesn't matter what you call the variable. But what I'm going to paste in there is the key that I copied from the console. Okay, so that's what an API key looks like that has been generated by API gateway for me. So I'll save that. And it's supposing now, as I've already said, the only endpoint that I have set as a protected endpoint is the get movie endpoint. So and I know this is a valid movie ID, so if I send a get request to this endpoint, and for now I am going to turn off this. So I'm looking at the headers here, right? And I'm going to turn off this header, which means there's no API key included in the request. And if I send that, I get forbidden, which would make sense. So that response is coming from API gateway because it expected to receive the API key and it didn't. If I now include the API key, so the header has to be called X X API key. The value is being taken from my collection variable that I just showed you there a moment ago. And hopefully, if I click, I'm now getting back. So the Lambda in this case now has been triggered and I'm getting back the movie data. So unfortunately, all I'm giving you is a demonstration of API keys working for a web API. What you need to work out is how do I actually code that in my stack file. As I said, it's only the stack file. There's nothing extra you need to do in the Lambda. Again, I'll pause in case anybody has any thoughts that they want to ask me about. No. Okay, if I go back to here, so these two slides, whether they're of use to you or not, these two slides are just at the end of the slide set that deals with API gateway. Now, if I go back to the assignment spec, there's something else I'm mentioning in the spec here, and it's called, I'm talking about custom constructs. So what am I getting at there? Okay, so I need to load a different project now into VS Code. So the CDK project we developed in one of the earlier labs, as far as I can remember. But let's just take a quick look down through it. So we've got our, am I looking at the right file? I don't think, am I looking at the right file? No, I'm not. This is the file I want to look at. We've got our movies table. We've got our movie cast table. We've got a local secondary index for the movie cast table. We've got our seeding construct. And we've got some lambdas. We've got a lambda URL, another lambda URL, then some permissions. Okay, so we've seen all this code before. And that's fine. And we know that, each of these things we call a construct. So this is a Node.js function L2 construct. This is well, that's not a good example. This is a DynamoDB table L2 construct. And we know what L2 constructs mean in the context of the CDK framework. Now, you can actually create your own L2 constructs, which I'm referring to as custom constructs. And when would you do that? You would typically do it if your CDK stack file is just too long, right? And you just want to break it up from a design perspective and make it easier for people that are reading your code rather than scanning down through a big long CDK stack file. You could take logical chunks of your stack code and put that into a construct class. Now, let's suppose we wanted to do that here, even though it isn't a particularly long stack file. So supposing I decided I'm actually going to take all the Lambda stuff and put that into a custom construct. And a construct is nothing other than just a class. And then I can create an instance of that class within my stack file, and it will have the exact same effect as leaving the original code in the stack file. So again, what I want to do, and I've just arbitrarily chosen that I want to take all of this code here, and let's say I stop here. I want to take all of that, cut it out, and put it into its own L2 class file or L2 construct. And so I've actually done that. And so if I go to this second file in the lib folder, this one here, and so let's look at this. So it looks like we're creating a class, or this file is create a class. I've decided to call it the movies lambda class. Note that in this case, it extends the construct superclass, whereas the stack file extended, go back to that class file, or that class extended the stack class. Yeah. So straight away we can see now that this second TypeScript file uh, is for a different type of class. Okay. We can ignore these two things for the moment. In this construct class, much like the stack class, it's only the constructor that we implement. And the signature of a constructor, the signature is always the same. It has three parameters. The first is what we call the scope parameter, and that's really the same, if we think of if we look at any other construct, like this construct here, or the first parameter here as well is a scope parameter, and it's always this because we're always attaching our L2 construct to the current stack. But for my custom L2 construct, the constructor has what we call the scope parameter. It has an ID parameter, which just needs to be a string, that it's a unique identifier for your custom construct. And the last parameter is what's called the props parameter. Now, that in our case will be used to allow us to pass some information into our custom construct. Now, in my case, I need to pass in a reference to the movies table and the movie cast table into this custom construct of mine, because the lambdas actually need to refer to the tables, as in here. But the tables are actually defined in the stack file. So I need to pass them from the stack file into my custom L2 construct. And anything that you need to pass into your custom construct, you pass them in via this third props parameter. The type for the props parameter you have to define as well. And so here I have defined it for myself using the type alias, or I could have used the interface, the TypeScript interface uh, mechanism for defining it. So here's my alias. I've named it that. It has two properties, and the types of the properties, if you need to work out, although it's pretty obvious what type these two properties are. They're both of type the table built-in L2 construct. And then the rest of the code in the constructor is really what you've cut out from the stack file. In other words, like I literally cut out, cut and pasted all the code starting from here. So what I'm going to do now actually is I'm going to comment out all of this. Yikes. And I'm going to replace it with this here. Just going to move that up first. I'm creating a new instance of movies lambda, which is my custom L2 construct, which I've obviously imported up here. Where did I import it? I think I've imported, oh yeah, imported it there. And I am attaching my custom L2 construct to the current stack, giving it that as its identifier. And here's what I'm passing down to it. Passing down a reference to my two tables that I've defined at the top of this stack file. Now, sometimes your construct needs to kind of return something, or you need to be able to access, sorry, let's put it that way. Sometimes you need to be able to access particular values within your custom construct. And in my case, because I'm doing this here, right? I'm outputting the URL of the function URL that's generated by my custom construct. In other words, if I go back to here, well, like I need to give my stack file access to that variable and to the other one for that's the one for the URL for the get movies by ID, and also the URL for the other Lambda. So those two Lambda URL variables that are generated within my custom construct, I need to make them available to the stack file. And the way you do that from a programmatic point of view is you make them public properties of your stack class. In other words, they're going to be public properties of an instance of this class. How did I work out the type for these variables, essentially? Class level variables? Well, they're instance variables. Well, how do we find out the type for anything in VS Code or in TypeScript? We simply go, Command K, Command I, and it tells us the type. So I literally kind of copied that, and that's what I put in up here as the type for both of them. They both happen to be the same type. That's just coincidental. Obviously, these can be different types of variables. So by making those two public variables or public properties of my class file, that means back in the stack file, if I need to refer to them, I simply go, where am I doing it? I'm doing it here, right? Movies lambda dot the public property name. This movies lambda is just this variable here that I've assigned from my, so this is an instance of this particular class. We know how object orientation works. So what I'm talking about is, if we just pull back a little bit, I've got a stack file. I've taken a logical chunk of code. By logical, you kind of have to decide yourself what logic chunk you take out of your stack file. You put it into a separate class which is a construct class. You of that construct class, you decide what variables within the construct do you need to make available to your stack class. And once you've decided on that, then you make those as public properties of the construct class. And the information or variables that you need to pass to the construct, you make those as part of the props parameter, which is the third parameter of the actual construct class itself. In other words, this parameter here, it's always going to be an object. The third parameter is always going to be an object, set of key value pairs. So in terms of the assignment, you just need to decide what section, and look, there are different, there's no right answer or wrong answer, but take a logical chunk of code from your stack file and create a custom construct for it instead. That's what I'm looking for in the assignment. I've given you really, I've given you everything you need to know. I don't think you need to. You can read up a little bit on it, but if you rewatch this video, you'll have a good illustration of it. Unfortunately, I'm not going to provide the code. That just probably makes it a little bit too easy, but again, I'll pause. Is there any questions? So just go back to my stack file. Can now obviously get rid of all of this code. my stack file now is just creating my two tables, seeding the table, create an instance of my custom construct, which generates all the lambdas, the lambda URLs, and that's it. And I've left the permission stuff back here. It's debatable. You could have put that into, but because it's more related to the tables, then I've left it here in the stack file. The outputs from this stack, and so my stack is now much shorter than it was before, which is the whole point of these kind of custom constructs. Okay, so I've tried to give you an explanation of that. Now, in terms of this stuff down here, I'm not giving any explanation on that, unfortunately, so you need to read up on that yourselves if you are aiming for this grade. The API key stuff you need to read up on as well in order to be able to meet that requirement. And the rest is doable without any extra kind of research on your part. Okay, you have to watch the video on doing that translation, but I think once you watch that, it should be straightforward enough for you, hopefully. So I'm not going to do any more stuff today. I've covered enough, really. So certainly I would strongly recommend, well, you need to submit it anyway, so you need to work through this lab and then tackle the assignment. And you can use the output of this lab, as the starting point for your assignment. I don't really care. But you do need to submit this, have a separate repo for your assignment, obviously, separate from the repo that you use for this lab. Does anybody have a question for me at this stage? No? Okay. So I'm going to finish early today. And I'll be in touch with you tomorrow during tomorrow's lab. Okay, thanks. Bye-bye.